right, if it's to be continuous at x equals -2. Alright, so you write for continuity at x equals -2. The limit from below the function, x approaches -2 from below, has to equal the limit from above, has to equal the value of the function evaluated at -2. That's the definition for continuity in this place, in this example, when x approaches -2. Alright. Well, here, if we're looking below -2 or above -2, right, I've got to use that part because here, this is the value at -2. What does it say? X equals -2, it's going to equal k. And then it asks us to evaluate what k is. So we're going to look at the limits each side. Alright. So, what do we do? Okay. So let's have a look at the first one. X approaches -2 from below. Alright, of what? Well, here, this means x approaches -2 from below. Or x approaches -2 from above. Not at -2. So it's this part that we look at. Alright. Now, the author of the problem, whoever made the problem up, wants you to know that that is a perfect square quadratic. And he wants you to know it is the perfect square of x plus 2. That's what he expects from you. So, he expects you to be able to do that. This is here, x plus 2 squared. Like that. This is what he wants you to know. Because in the event that you can write it like that, that means from go from here to here, right, then you can algebraically simplify the problem. Okay. Okay. So, what have we got? X approaches -2 from below. We want to cancel this here. Let's see what we've got. X approaches -2 from below. Alright, so if I add 2 from both sides, I get x plus 2 approaches -2 from below plus 2. Alright, so it looks like here x plus 2 is approaching 0 from below. Alright, now what that means is, if it's approaching 0 from below, x plus 2 is less than 0. Alright, so we go back over here to the definition. Absolute value. When x is less than 0, absolute value of x is -x. Here I've got x plus 2 is less than 0. This part, it must be equal to negative what's inside the absolute value sign. So here, this is limit. X approaches 2 from below, x plus 2 squared. And here now, instead of absolute value x plus 2 or mod x plus 2, I can write negative x plus 2. Yeah. Alright, now, even though it's less than 0 or negative, it's not 0. It's only approaching it, but it's not 0. So as a result here, I can do that. Cancel. Alright, so we get the limit. x approaches 2 from below of what? It's just going to be, here's the negative sign, limit, x approaches 2 from below, and it's going to be negative x plus 2. Alright, so here x is approaching 2, so it looks like the limit there from below is that, negative 4. Right, now that's from below. Now let's have a look from above. If I look from above, I can argue symmetry here about negative 2. I know that's a perfect square quadratic. I know what the graph looks like. Here we are, negative 2. The graph comes down and it bounces here. Right, that's for the quadratic. And then for here, right, the absolute value function has just been shifted off. It's going like this. Right, so as a result, we've got two functions that are perfectly symmetrical about negative 2. So I expect the limit in both cases to be the same. So let's have a look. Alright, now, from above. So I've got x approaches negative 2 this time, but from above. Alright, so I'm faced with the same thing. It's x squared plus 4x plus 4 over mod x plus 2. The author wants you to know it's a perfect square quadratic. And here we've got mod x plus 2. Alright, so I've got the limit. X approaches negative 2 from below. Alright, I can, this time, I've got x plus 2 all squared. Now, I have to replace the mod x plus 2 again. Alright, well let's have a look. X is approaching negative 2 from below. X is approaching negative 2 from below. No, above this time, sorry, like that. Alright, so if I add 2 here, you get x plus 2, you get negative 2 plus 2. Alright, so x is approaching, x plus 2 is approaching 0 and from above. Alright, now, in this case, it looks like x plus 2 here. What has it got? X plus 2 here, it seems to be positive. Alright, so the absolute value of x plus 2 should be equal to, what does it say? Greater than or equal to 0, the absolute value is just equal to the number, just equal to the value. So it'll be x plus 2. Alright, so I can cancel again. And I give the limit. X approaches negative 2 from above of what? X plus 2. And this time I get x approaches negative 2, it's 0. Now, somewhere I've made a mistake, because the one from to the right is 0, so back in here there's got to be an error from below. Let's see. There, x approaches 2 from below. Alright, now I've got mod x plus 2, that cancels, negative goes there, x approaches 2 from below. It's 2, it's not negative 2. No, it is negative 2. Yeah. There, it's negative 2 plus 2. And that's 0. Alright. So here's the limit from below. Here's the limit from above. Alright, it says, right, here this is 0, this is 0. Right, what will the value of the function have to be? Right, we can write there, f of negative 2 will have to be the same as each of the limits. It will have to be 0. And that's number 3.